Hello again. Today, inshallah, we will take Module 6, Lesson 3, Water and its Solutions. Let's start with the focus question. Why do things dissolve in water? What will be found in the water that makes things dissolve in it? We will answer this question at the end of the lecture. So let's start with the new vocabulary: polar molecules, van der Waals forces, hydrogen bonds, mixture, solution, solvent, solute, acid, base, pH, and buffers. Let's start with this type of vocabulary: physical property. What do you mean by physical property? Characteristics of matter, such as color or melting point, that can be observed or measured without changing the composition of the substance. Again, characteristics of matter, such as color or melting point, that cannot be observed or measured without changing the composition of the substance. Let's start with the intermolecular force. There is multiple types of force called intermolecular force. Let's start with the polarity. What do you mean by polarity? Which is the property of having two opposite poles or ends. Molecules that have an unequal distribution of charges are called polar molecules, meaning that they have oppositely charged regions. Water has a highly negative end and two slightly positive ends, therefore it's polar molecule. Look at the structure of the water. This is the water molecule, this is the oxygen, this is here two hydrogen. For the oxygen it's slightly negative here, and for the both hydrogen it's slightly positive. So which we have two different ends. One of them is negative and the other is positive. So this is a polar molecule. Again, this is a polar molecule. There is another type of intermolecular forces called van der Waals forces, which is regions of opposite charge cause weak electrostatic attraction between molecules. We call it van der Waals force. These attractions cause intermolecular forces, and intermolecular forces determine physical characteristics like boiling and melting point. Again, intermolecular forces determine physical characteristics like boiling and melting point. We have also another type of bonds called hydrogen bond. What do you mean by hydrogen bond? A hydrogen bond is a specific weak interactions involve hydrogen atom with one of the following, either fluorine, oxygen, or nitrogen atom. If there is any end or any molecule that containing fluorine and other molecule near to it containing hydrogen, there is a hydrogen bond will form. Or if there is a molecule like water and another molecule that containing hydrogen, the same molecule in the same solution, the oxygen and the hydrogen will bind with the hydrogen bond in between. So when a charged region of the polar molecules comes close to the oppositely charged region of another polar molecule, there is a weak attraction formed. Hydrogen bond is a strong type of van der Waals forces. Again, hydrogen bond is known to be a strong type of van der Waals forces. Let's now start with a mixture. What do you mean by a mixture? A mixture is a combination of two or more substances in which each substance retains its individual characteristics and properties and at the same time are either homogeneous or heterogeneous. So we have two types of mixtures, either homogeneous or heterogeneous mixture. From the name, what do you mean by homogeneous and what do you mean by heterogeneous? Homo means similar and hetero mean different. Okay, homogeneous mixtures, when a mixture has a uniform composition throughout, we call it homogeneous. And a solution is another name for a homogeneous mixture. Homogeneous, it's a uniform composition. In a solution there are two components, either a solvent or solute. A solvent is a substance in which another substance is dissolved in. So the solvent will dissolve the solute. A solute is the substance that dissolved in the solvent. So for each solution, we have we have solvent and solute, and the solute will be dissolved in the solvent. While the heterogeneous mixture, when the component in a mixture remain distinct, it is a heterogeneous mixture. A suspension is a type of heterogeneous mixture. Suspension, like a milk in a water, okay? It's a heterogeneous mixture in which the particles settle out over time. If you lift it over time, there is something that will be settled down, okay? A colloid is a heterogeneous mixture in which the particles do not settle out. Again, a colloid is a heterogeneous mixture in which the particles do not settle out. So, with the heterogeneous and homogeneous, you can define the meaning of heterogeneous and homogeneous again. Again, homogeneous, what we mean by homogeneous again, look at it again. It's a uniform composition that containing solvent and solute in the solution. And the heterogeneous one, it's a mixture, okay? Distinct mixture, like suspension or colloids, okay? So we have two types of heterogeneous, like suspension or colloids. Okay, let's watch a video now about the mixtures, and then we will complete the lecture. Thank you. Have a nice day.
Imagine a mixture as a blend of different substances, like ingredients in a recipe. Now let's focus on the differences between homogeneous and heterogeneous mixtures. Homogeneous mixtures are like perfectly blended smoothies. In these mixtures, the individual components are so thoroughly mixed that you can't see them separately. Everything looks the same throughout, and the properties are uniform. Think of a glass of well-mixed salt water. You can't distinguish the salt from the water because they've merged seamlessly. On the other hand, heterogeneous mixtures are more like a colorful fruit salad. In these mixtures, you can clearly see the different components, and they're not evenly distributed. Think of a bowl of cereal with its various shapes and textures. Each part stands out distinctly. Now, why are these distinctions important? Homogeneous mixtures ensure consistency. This is super important when making medicines or even tasty treats. If the mixture in a cake batter is wrong, it may not rise evenly. And if the exact ingredients aren't mixed into a medicine, it may not work properly or safely. Likewise, in things we use every day, like food or gadgets, we want them to be the same quality every time. Homogeneous mixtures help make sure products are consistent. So that's the scoop. Understanding homogeneous and heterogeneous mixtures is like having a special key to unlock secrets in cooking, science, and creating amazing things.